On today's episode, we are getting into the latest space news, including China releases new plans for an international moon base, SpaceX helps the ESA launch a dark energy telescope, and the US Defense Department invests in sea launch platforms. This is the space race. The People's Republic of China is building an international coalition of space agencies to help them construct an advanced research base on the moon in the 2030s. In a recent update to their plan for the International Lunar Research Station Initiative, China's space agency announced that they are actively recruiting new member countries to join their future plans to colonize the moon. Now, the obvious way to look at this would be an antithesis to the US-led Artemis Accords, which now includes 27 countries. We are going to try and avoid framing this as an us versus them kind of deal, though you are free to draw your own conclusions. China's ILRS moon base was initially presented in 2021 as a joint venture between China and Russia, but is now expanded to include Pakistan, the United Arab Emirates, and the Asia-Pacific Space Cooperation, which includes Turkey, Mongolia, Thailand, Peru, Iran, and Bangladesh. China claims that there are an additional 10 countries and organizations currently in negotiation to join the initiative, among them being Malaysia and Venezuela. I think it's fairly obvious why China would make the decision to diversify their partnership on this one. The headquarters for the new international initiative is located in Deep Space Science City, which is apparently a real place in the Hebei province of China. And this is a center focusing on design simulation, operation control, data processing, sample storage, and international training. Artemis has too many countries to list here, so we'll just put the graphic up on the screen. This is up to date and includes the latest member nation, India, who signed on in June and brings a well-established space agency into the mix. You'll notice that the UAE appears on both lists, so this is not a matter of picking one side or the other, not yet at least. We'll see what the United States has to say about this, more on that in a bit. The primary goal that China has put forth is to construct a permanent lunar base in the 2030s with a series of stepping stone missions that will be launched before the end of this decade. So unlike Artemis, China does have a very clear roadmap to establishing their physical presence on the moon. The ILRS base itself will be constructed by 5 planned missions that leverage China's upcoming Long March 9 Super Heavy rocket. These will establish nuclear energy, communications, astronomical observation, and other infrastructure for what will initially be a fully robotic research station, but will later host Chinese taikonauts and potentially crews from these other member nations. There's even a future concept to use ILRS to validate technology and capabilities for a crewed mission to Mars. The Chinese Space Agency also released their new concept for a communications, navigation, and remote sensing constellation of satellites operating in cislunar space, using relay stations positioned at Earth-Moon Lagrange points and in geosynchronous Earth orbit, and these would be linked into China's existing Beidou satellite navigation constellation. This will begin early next year with China's deployment of a new relay satellite into a high orbit around the moon, and the purpose of this new satellite is to support the Chang'e 6 robotic mission to the far side of the moon, which will be the first ever sample return from the far side of the moon and is scheduled to launch in May 2024. This will be followed up by Chang'e 7 in 2026, China's most ambitious lunar mission consisting of an orbiter, lander, rover, and hopping spacecraft designed to seek out water ice in permanently shadowed areas of the Shackleton crater. Chang'e 8 will launch 2 years later and land nearby Chang'e 7, carrying a robot designed to test 3D printing bricks from lunar regolith. These 2 missions will serve as a basis for the full ILRS project to follow in the 2030s. Taking an optimistic view here, this is all fantastic news. We have basically every major nation on Earth working in partnership on 2 incredible plans to extend human civilization onto the moon. But this isn't Star Trek: The Next Generation, and we are nowhere near settling our conflicts here on Earth yet, so it's hard to believe this won't quickly turn into another arms race. The biggest issue at play is the United States, who has been steadily ramping up their hardline approach against China. In addition to militarizing the Pacific Ocean, which is a whole other thing, the US has prohibited sharing any American-made technology with the Chinese. So if an Artemis Accord nation wanted to participate in the Chinese initiative, they can't bring any technology with them that contains even one US-designed microchip, and considering the USA is home to Intel, Nvidia, AMD, It's basically impossible to avoid these trade regulations. As much as you hate to say it, we're basically watching the nations of the world pick sides in the new race to the moon, and the competition is heating up. On July 1st, the SpaceX flight team at Cape Canaveral shepherded a Falcon 9 rocket into orbit. Tucked safely into its payload fairings was one of the most important experiments the European Space Agency has ever built, Euclid. The $1.5 billion space telescope is equipped with an almost 4-foot wide mirror, a 600 megapixel visible light camera, and a 64 megapixel infrared spectrometer. Euclid is on a mission to crack one of the biggest mysteries of our universe, the nature of dark energy and dark matter. Most of us are relatively familiar with dark matter, at least. It's the subject of many sci-fi tropes, and its depiction of some dark-colored mysterious goo usually makes astronomers sigh in frustration. This is because the dark in dark matter refers to the fact that we can't see it, meaning it's invisible as far as we can tell. We don't even know if it's matter at all. When we first started really mapping the universe back in the late 1990s, scientists noticed that the expansion of the universe was increasing in speed, which was weird because as galaxies and solar systems drew further apart, it would make more sense for the expansion to slow down. Unable to pinpoint a cause, scientists hypothesized a new force, which they took to calling dark energy for lack of a better term. Similarly, they came to see the effects of matter they couldn't detect, which became known as dark matter. As best as they can tell, astronomers believe that dark energy makes up almost 75% of the energy load of the universe, with dark matter making up nearly 24% of the universe itself. For reference, current estimations of normal matter, the stuff that makes up planets and stars and people, is only 5% of the universe. That's a big part of the universe that we can't detect. It would be like not being able to find air even though we all know it's around us. So then, how does the ESA expect to find dark energy and dark matter with a telescope, when both phenomena don't emit or reflect light in any spectrum we have access to? Well, we have been able to measure their effects, which means we just have to get tricky with how we spot it. The most basic function of Euclid will be just to watch. By taking a long time studying specific galaxies, the telescope should be able to take note of even the most minute changes and rule out things like gravitational anomalies or changes to observable radiation. Once those are canceled out, what remains should tell scientists a lot about the effects of dark energy. But the second function of Euclid is more active. The telescope will find and image over 10 billion galaxies. An algorithm will help sort out about 1.5 billion of those to be candidates for closer study, and they'll be the galaxies that already show a bit of shape distortion that could be signs of dark matter. From there, Euclid will use a trick we've discovered to see if it can spot dark matter indirectly, a technique known as weak gravitational lensing. Using the gravity of stars, black holes, and close galaxies, Euclid will take in the light that has been bent around all these gravity wells, and in this way, astronomers think they might be able to finally catch a glimpse of dark matter clouds. Over 1,500 scientists at 9 different research groups will be sifting through the data Euclid brings in for years, assisted by powerful computers running extremely sophisticated software. But figuring out the dark energy puzzle is immensely important to understanding our universe, and the answers could force us to change how we view even basic physics. A new launch startup has just scored a huge investment contract from the US Department of Defense. The spaceport company announced their good news on June 5th in a company news release. The new company was one of 17 chosen to receive funding under the Pentagon's National Security Innovation Capital Program, and their work with proving the functionality of offshore launch platforms has landed them $1.5 million of fresh capital to continue the development of their floating spaceports. This funding was almost certainly awarded to the spaceport company in response to their successful May 22nd test in the Gulf of Mexico. With the help of a company called Evolution Space, they piloted their prototype floating launch platform out into an undisclosed area of the Gulf and launched a small test rocket. Some of you looking at this prototype could possibly be noticing some similarities to the SpaceX drone ships that serve as landing pads for some Falcon 9 boosters, but that's likely only because of the need for waterborne launch platforms to be shaped relatively flat, and barges make for very easy starting points when designing something like this. The large poles on the vehicle are for stability. Company simulations show that for full-sized rockets, the poles will deploy below the craft to cut down on excess movement. That said, it's hard to think that the spaceport company hasn't been influenced by SpaceX at all. Not only did SpaceX pioneer landing boosters on their modified barges at sea, but up until February this year, they had plans to use 2 decommissioned oil rigs as mobile offshore launch platforms. Obviously, SpaceX had bigger fish to fry with getting Starship up and running and sold off the rigs instead of pursuing that idea. But that doesn't mean it was a bad one. The spaceport company wanted to take over from SpaceX and put their own spin on it, of course. The idea is for the first smaller barge-like platform to get the company some contracts and more funding. From there, the company plans to develop larger vessels, creating, in their words, the first truly commercial spaceport. Aside from that, though, launching from just offshore is a particularly good idea if you can manage to stabilize the platform on the waves. Away from shore, there's much less traffic, either from water or aircraft. Think how many times rockets launching from Cape Canaveral have had to call a hold because an errant fisherman or distracted cruise liner wandered into the danger zone. And it's not hard to understand why rocket companies would love to launch far away from all that mess. But perhaps more valuable is the idea that there's very little collateral damage that can happen out in the ocean. Should a rocket fail or burn too strongly, the damage would only include the platform and the rocket itself. No rain of concrete, huge dust clouds, or dangerous debris. The final benefit, and the one that the military is probably most interested in, is the versatility. The spaceport company boasts that their vessels would reduce the time in between launches because there's less to clean up, and so the platform just chugs back to port, picks up another rocket, and turns around to head back out to sea. Again, the lack of traffic and next to no collateral damage means that this sort of system could be rapidly deployed from almost any harbor. That has implications for launch capabilities that goes beyond just spacecraft. But the DoD has said they are also interested in figuring out how to launch satellites quickly to counter threats, so that's why the spaceport company landed $1.5 million to work this system out. Military shenanigans aside, this is a good system. The folks at the spaceport company have zeroed in on a big need in the commercial launch services market, one that SpaceX obviously saw earlier but wasn't able to capitalize on. The ability to launch freely from bodies of water well away from the delicate infrastructure and population centers is just too useful an idea to have died when SpaceX dropped it. So let's hope the spaceport company can get their platforms up and running in time to score more funding. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.